Welcome everyone. Today is July 8th, and this is another of our bi-weekly SIG Apps meetings. My name is Nachi, and I'll be your host today. Quick announcements, Code Freeze is in 2 weeks, July 23rd. There's a link to the full summary because the exact time and date might differ by a few hours depending on where you are. And with that, we can jump right away into the main topic. Weiwen, do you want to share your screen, or is it just sufficient if I show the enhancement?
Okay, I will share my screen.
Okay, let me make you a co-host, and I'll stop sharing. You should be able to share now.
Okay. 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 Oh, I will need to restart my browser to give it permission.
Okay,
Sorry.
we'll wait. Yeah, no worries. Caitlin, how long is your topic while we're waiting for Weiwen? Yeah, that's what I was expecting. Do you need, I don't know whether Clayton or Caitlin, you're going to talk about that one?
Just wanted to have a discussion about it, just to see what everybody was thinking on whether or not that would be a good idea.
I looked quickly at the PR because you've added that just before the call, and I had a quick look. Theoretically, it seems reasonable. I know we're currently changing the PDBs and promoting to GA the bit which is responsible for the unreadiness. I would have to double check if adding this kind of check would be a breaking change. But after a quick look, theoretically, we should be okay. But like I said, I'd have to double check.
I would say that it would be surprising to consider a pod that hasn't passed its readiness gates, which means it's not actually serving. To consider it ready, I think would actually accomplish the opposite objective of what PDB is supposed to. So I think there's at least an argument for the readiness gates should be taken into account. But I haven't looked at the issue in depth either. I would be the one I would be worried about, because I have been looking a lot at pod readiness recently, would be we need to do a better job of defining when something is in rotation. That's actually what my issue is about, because like we want to only add workloads to endpoints when they are certainly ready, but we need to aggressively remove them from endpoints when you are probably going to be disrupted in the future, because the way that endpoints work in Kubernetes is that the consumers of them may take time to propagate. So like, adding a new ready endpoint, it might take seconds or tens of seconds before you're added to rotation. Removing, you may have to wait similar amounts of time, which means if you're deleting a pod or a pod's about to get terminated, the sooner you act, the better. So I will say I'd be worried a little bit about the interactions of this with Ready. And my issue is related enough to it that I was actually looking for feedback. I think we need to have a broad feedback on what readiness means in Kubernetes and how it is interpreted by multiple components. The ones I've been focused on were there's a whole bunch of bugs right now that need to be fixed, which is partially what triggered getting to this, which was we don't continue to check readiness when pods are being shut down correctly. And so pods stay ready longer than they should, or the value of readiness is actually incorrect. I think that could have an impact on this as well. I don't think it would have an impact on this in a way that would prevent the check readiness gates from being reasonable, but I do think that we may actually want to have a one doc or something that's really concisely states what readiness and PDB and shutdown all mean together.
But you're not targeting 31 for that because that seems like a bigger topic. The other one just took right over.
Well, I think we would need to. I think maybe my suggestion would be for this one, we need to determine whether not implementing this would result in PDBs failing to provide the guarantees that a user would expect. If so, I think that would be an argument for doing it regardless. The discussion I was having, yes, there's two parts. There's what we need to do to make graceful shutdown get to stable, because I think this is actually a blocker to that, because if you gracefully shut down, your pods keep getting served, and so they actually get disrupted unexpectedly. So that could be, there's parts of that might be 131 as quick fixes, but more likely it would be a 132 thing.
Okay, I'll definitely have a look at it, and as well as Caitlin's PR, and see what we can. But yeah, definitely with the assumption that if the readiness gates are not passing, we're also not passing the readiness. I have to play a little bit more. I will admit that I haven't touched readiness gates so far, so I need to double check that bit. Cool, thank you. I guess we have. Oh, does anyone have any questions before we go back to Waitman's topic? No. Okay, cool. Thank you very much, Clayton and Caitlin. Waywan, go ahead.
Thank you. I think I have a notice that said the host has disabled the screen sharing.
Oh, right, because you rejoined. I need to give it back to you. Now you should be able. Sorry.
Okay. Okay. Can you see my screen?
Yep.
Okay. So here we want to discuss about these three questions. Okay. And the first one is okay. Let me just talk about the background in 1 minute. And we do want to propose a new cap that is to enable stateful set for updating volume claim template. And currently the template is immutable, and we want to update it for mainly two reasons. The first one is we should propagate the changes from template to PVC so that we can do the expansion or the modify volume things. That is the VAC. And the second purpose is to affect the newly created PVCs, whether it is recreated because of the old PVCs are deleted or the stateful set itself is scaled up. Okay, so the first question is, do we want to allow editing all fields or only allow editing the storage size and the VAC? And my initial proposal is editing all fields should be allowed. And this is because all the fields will affect the newly created PVCs, so not only the existing one. And any opinion?
Right. So based on the feedback that we gave you the last time, the majority of us said that we are advising you to start small and start just with the storage, and then slowly we can expand the enhancements into adding additional changes. That was also the idea behind the initial cap, which, if I remember correctly, was number 661, which was only talking about the ability to increase the volume size and nothing more. So I would definitely, and if I remember correctly, that was the direction that we were talking about the last time, and that's what I was hoping to express also in my comment earlier in that proposal.
Okay, and so yes, so we are going to only allow storage size. And what do you think about the VAC, since that is the another cap currently alpha?
Right. So I would, given that the cap is alpha, I would not try to rely on it until it reaches GA. There's a high possibility that something might break, or there will be delays on the enhancements implementation, or they will run into various roadblocks. So relying on a mechanism that is alpha is usually not recommended. I'm not saying that we cannot revisit this topic again, like with the rest of the fields, but that was basically the goal that we had, is gradually reconsider what we're doing and expanding the feature as necessary.
Okay. Okay, so we should focus on storage size now. So the second question is, what should we do if the template and the PVC does not match? And we have three possible strategies. That is, the first one is just skip. Don't touch the unmatched PVCs, or block. That is, stop the rolling update and waiting for the user to take action. Or we can proceed anyway. That is, regardless of other immutable fields, and just do the resize the user requested. And the proposed default strategy in this cap is just a skip. And so and there's a field that user can enable it explicitly to block on the mismatched the mismatching. So but in the original cap 661, the author wants to proceed anyway. That is, we think this strategy is not properly, because first, So let's take this VAC into consideration. That is, the volume attribute class is strongly is just a part of the specific driver. That is, if the storage class don't match between template and PVC, then we cannot update the VAC to the desired class. So if we consider this for the future iteration, then we should not take this proceed anyway strategy. And so any opinions?
Can you remind me why we would get into the point where the storage class doesn't match the template or on PVC?
And mainly because there's a possibility that the PVC are created before the stateful set. So the stateful set just adopt the PVCs.
So that means from the start you have a mismatch between the template and the PVC.
Yeah. So
up until today, and the majority of the problems and the design decision that we've made with the stateful set was that if there are problems that we cannot act on, we usually blocked further rollout and required a manual user intervention to fix the state to something that will allow them to unblock. The reason behind that kind of approach was to ensure that the data, which this particular stateful set is exposing through, whether that'll be a database or something else, is always safe at any cost. So I will probably say that in that case, we would just block the upgrade. No skips, or definitely not proceeding anywhere, but require a manual integration. If I remember correctly, there are even places in the doc where we require users to fix a broken state of a stateful set before we will be able to move forward.
Yeah. Okay. So, but the stateful set may be, the PVC may be very hard to fix. The user may need to delete the PVC, and that may just delete the underlying storage and clear their data. So clear the PVC is very very hard work.
Well, a different alternative is to create a proper PVC, copy data over, and only then remove the broken PVC. And that's probably the one that I would go with.
Yeah. So yes, but that cannot be used with stateful set because the name of the PVC is given in the template, so you cannot create the two PVC with the same name.
Right,
Okay.
but you should be able to even eventually do a double migration. This way you'll be able to recover the old name.
Yeah. Okay, so maybe we should go for block by default. Okay, so the last one, and should we support kube control rollout undo for the templates or not? And if we support undo, then we then that means we should disable the validation of the templates, because if we do the validations like in cap 661, that which propose to disallow the decrease in the size of template, that would prevent us from undoing the expansion. So my proposal is to support kube control rollout undo and disable the validation. And if we have any issue, then we should just show that in the status instead of when user applying the template.
There's a potential risk that because you already started the rollout and you're going back in history, the data has been written in with the extended size. So what I would probably say is, because the rollout where you would allow the size to go down would break the validation, and you would have to complicate the validation rules such that it would have to know that this is a rollout and not just another upgrade. And people could probably then bypass that validation through this mechanism. I would probably say that we can remove the size from the template when rolling back the stateful set. If I remember correctly, we have a couple of exceptions, fields that are not being restored. So that would be just a matter of properly wiring kubectl rollout undo such that it does not affect the PVC size, the PVC template size. That would be the simplest and the most reasonable approach, because a lot will depend when you're going back with the rollout, which would make the validation very hard, because you would have to maintain the information how quickly after the new you're going back to the old one, and trying to figure out whether a user is allowed to decrease the size or is not decreasing the size, which unnecessarily complicates the validation logic.
Yes.
For
So
the
why not
volume
just
increase.
disable the validation for the template? We just don't limit the decreasing of template size. If the user really decrease the size, then we don't block. And let's say
but the whole goal was to ensure that we don't break users, because if we suddenly allow decreasing the size, you might break user data, whether accidentally or on purpose.
Yeah, we just allow decreasing the template, and if the user decreasing template, then we will not touch the PVCs and leave the normal PVCs just normal. And if the PVC is expanding and maybe triggering some asynchronous failures, then we will try to cancel the expansion and undo, to try to undo the expansion. And this is another cap which tries to recover from failed expansion, which is also alpha, I think. So my idea is we allow decreasing the size of template, and when decreasing, the normal PVCs are left normal, and the failed expansion PVCs are cancelled.
So here's a different way of looking at it. From the past, we know that usually making a validation stricter is a safer bet, because if at some point in time there will be a capability which will allow safely shrinking the volume size, at that point in time, we might want to revisit that option and then loosen the validation such that we will open it up for decreasing the size. But it's safer to start with a very tight validation where we will only allow increase in the size, so either the same or bigger. But the moment you try to decrease the size, we will not allow that change. And then eventually, if at some point in time, this functionality will be safely implemented in majority or some or all of the CSI drivers that we support today, then we can reconsider and just drop the validation. But if the opposite happens, that means if Kubernetes will not deliver the ability to decrease the size safely in the near future, then without the validation, you're in a half-broken state. Whereas with the validation in place, you will have at least a consistent experience. And in the worst case, you can always recreate a full stateful set if required, and copy data over, migrating from one stateful to another one, because we already have capabilities like that today.
Yes, but and go back to the question, that is, if we do the validation, then we will not going to roll back the size, right?
Right.
So
that is correct.
I think that is not very desirable. I think as an operator, I do want to really undo my operation.
Right. The problem is that you cannot safely tell whether a undo operation is, because if the previous change broke or not, or how fast it broke you. And being able to decide whether the decrease would be a safe operation or not is not the one that you can.
I think we will not support decreasing the size of a PVC. That is, I don't want to support that. I just want to, I just want to change the template.
Correct.
I think,
but if you're rolling back, but if you're so the validation and the rollout, the undo, are both connected, because from the API server point of view, a rollout undo is nothing more than a patch operation, which eventually at the API server validation level will be seen as yet another update to a resource.
Yes.
So you need to make sure that you will pass the validation, which will prevent you from decreasing the size of your volume clean template. So you need to make sure that this is not reverted back.
So I still don't get that. What will we get if we don't allow the user to decrease the size of the template?
We will get confidence that we're not breaking the data.
Yes, but the PVC validation is already ensuring that we will not decreasing the size of PVC. So another layer of validation at template may be not necessary.
Well, it's better to do a double validation than allow, because if suddenly a PVC validation changes, we have to make a conscious decision whether we will support it or not on the stateful set level.
Yeah. Okay, so so I'm still not convinced in these topics. So I still want to, so in the cap, I'm describing that when rolling out an update to the PVC, we are waiting for a PVC to be compatible, which is similar to the readiness to the pod. When we see a PVC is compatible, we check that the PVC size is larger than or equal to the template size. So in this design, if user decrease the size of template and the PVC is left in a totally valid state, it is just larger than the template, and it is a stable state that we will not even try to decrease the size of PVC.
Right. But in that process, you have to go through a update to a stateful set object. During that update, you have to pass the validation, and that validation will not pass because you decrease the size, which
that's why we
by default will not be allowed.
Yes, that is why I want to propose to disable the validation to the template.
Right, but we are immediately opening up for a whole field of potential problems that users will struggle or accidentally break their own stateful sets. So that's why we want, and like I said earlier, it's better to have a stricter validation initially and over time loosen it up than the other way around.
Yes, but if we don't support undo the size, then can we enable that in the future? Maybe we cannot do that either.
Yes, we can, when we will decide that we want to allow decreasing the size of the PVC template.
Okay.
They will be connected. So when you will allow the decrease in the size, you will be able to also modify the rollout undo. Because at that point in time, the rollout undo operation will pass the validation. But without it, you cannot modify that kind of, you cannot do that kind of update to a valid update to a stateful set object.
Okay. And so another point is that I just talked about the recover from failed expansion topic. So another point why we want to decrease the size of template is that we can use the decreasing of the template size to trigger the recover of expansion failure feature. So I think this is also desired. And if we don't allow the decreasing, maybe we can do another complex validation that if some PVC is failing expansion, then we allow the decreasing. That is too complicated, I think.
Right, but if I'm looking correctly, the recovered volume expansion failure feature is in alpha since version 1.23 and hasn't moved anything for the past 8 releases, which puts this particular claim of yours at a high risk if we decide to enable it. Because an alpha feature that hasn't progressed for this long, I would claim that it is either not functional or there are major problems that need to be solved first before we will be able to enable this thing.
Okay.
I'm not saying that we cannot visit this topic once that particular feature, and the same applies to the VAC. When both of these will be moved forward, well, attribute classes, when both of these will move to at minimum beta and ideally to GA, then there's nothing stopping us from revisiting. But at this point in time, it's a safer option to allow only for a smaller set of changes, which in this particular case is only allowing increase in PVC template size.
Okay, so that should not be a big change to the implementation. That is just add a validation to the API server. So
Correct.
okay, so we will talk to the SIG storage to check the state of that two storage caps. Okay, thank you.
Definitely. Thank you very much. Okay, I guess that was the last topic in the agenda. Let me double check. I don't see anyone. Does anyone have any last minute topics? Hearing none. Thank you very much all for today, and see you next time in 2 weeks. Bye all.
Okay, bye.